Here's my air handler. We got nothing going on except it's hot inside. It's a steam coil inside of here. So we're gonna open my panels up. First thing I need to do is an actuator right there for the supply steam. I need to turn it off. Try to cool it down in there. I haven't done any diagnostics except for there was no power. This is my controls back here. This is the 600 that controls this unit. So this just has a bunch of inputs and outputs to control this unit. I had no power, tripped a breaker. So you can see I've got low voltage power now. I've got my disconnect actually turned off. So transformer's probably fed from the incoming voltage. Because I do have, off, and I'm off here. So we need to diagnose. Really the only thing that would have caused the trip breaker is something electrical in the panel or that motor. So we're gonna dig into that, and then we'll, after we turn the, because I'm gonna have to crawl inside there to get that motor pecker head. And it's steaming hot in there right now. So let's get the valve closed, go from there. I've got to do better with my cords. This is ridiculous. One cord I needed was wrapped up nicely in a rubber band. So we got USB A to B. You can plug into here, but we're gonna go directly into the controller here. And then plug into our USB. And then we've got Trane TU or Trane SC. I think I gotta use TU to plug into a 600. SC can plug into an SC, obviously. TU can do both. So let's get plugged in and connected. So we're gonna connect, direct connection, connect directly with a USB cable. We'll give it a second, and it should pull up my 600. So 75 into space. Let's go to analog. So I've got analog inputs and outputs and analog values. There's been steam issues on these, air vents problems. So what happened is we set the valves open all the time. You can see 100% valve set point. This is my heating valve command to 100. So let's see if we can't edit that heating valve command. You can see it's going off voltage. It doesn't really tell me what kind of voltage. Yeah, there you go, 0 to 10. So 0 is 0 and 10 is 100%. Let's try to do this, override. Little manual life safety and no duration limit. We're gonna undo it when we get done. Requested value 0. Apply. So my command is at 0 now. I've overridden it, so I'm bypassing the set point. The set point is on outdoor temperature, so they were originally supposed to close at like 50 degrees outside and not allow steam to come through. Well, they've had problems with the air vents. You can see some steam coming out of this when we open that valve up. We're gonna let everything cool down. But the air vents started failing and started spitting water out, which I don't necessarily know that it's all the air vents problem and not return problems in this building. These aren't bad because they go down. Some of these run up. I've done some other videos y'all have probably seen, but some of these run up to 20 feet. So you're pushing condensate back 20 feet. So they've had all kinds of issues that we've resolved. First of all, they turned off all the air vents. And then when the valve closed and tried to open back up, we had air in the system. The air didn't bleed, so nothing heated. So they raised the pressure, and finally I said, y'all are gonna blow something up, stop raising the pressure. So we got that valve off. The other thing to keep in mind is confined space. Know where you're at and what needs to be done. This isn't necessarily gonna be a confined space, and I've got a disconnect right here, but you may need a confined space permit. I know they have oxygen monitors. When I've done some brazing inside of these before, I wear an oxygen monitor or have it around me. So some things you got to keep in mind on these sites. And we don't always think of heat as energy, but you can feel the heat here. I didn't want to get in there because it was hot, but I also have steam in this coil. So if something were to happen, I don't want to be inside of here with steam in this coil. We are going to open this up, check power shortly. We'll go through and see if I can see anything wrong with the motor. And then if we have to trace my wires back, we may have to follow the wires back to the motor and see where we get from there. But I have a feeling they had some power surges and stuff, so it's possible that a power surge tripped the breaker. The overload inside of here, it's got an overload contactor, was not tripped. So we're going to investigate all that after this cools down. So while that guy's cooling down, we're going to come in here, check our voltage. We got disconnect off, so this is my power feed right now. I've got power here and to the top of my disconnects, so nothing coming out on this side. It does, like I said, feed the transformer, so we ought to be able to check power right here. 489. I think that's the one I did first. 490. So I've got three-phase power. Overload is not tripped. Looks like, it's hard to tell. Okay, there's an arrow there. So it's set on like 5 amps. So let's, I've got power off. Let's check my fuses. I'm just gonna do continuity. We're good there. We're good there. I'm good there. Okay. So let's see if we can ohm through the motor from here. Can see really well, but that's 1 to 2, 4.0. 1 to 3, open. Well, maybe that's my problem. I'm reading open there. 2 to 3, I'm reading open there. So, kind of like I said before, I'm reading open, so this is going straight to my motor. That's my power feed there, so I need to verify that I've not just lost a wire, that my motor's actually open. And then we'll go from there. Belt's pretty tight. We're starting to cool down, so let's get that off of the motor and see See what the inside looks like. Maybe we burnt the wire up or something like that. Maybe we got a bad motor. Now, got air coming in here. These are 100% outside air. That's part of my issue with the control sequence that it operates on is space temperature. So when space temperature satisfies at 72 degrees, the face and bypass damper, which basically encapsulates that steam coil, you can see it's cracked a little bit. I did that to try to allow some heat to flow, because if it closes 100% and it's below 32 degrees outside, or right around 32 degrees, I trip my freeze stat. It was never set up correctly, but I've got a face and bypass damper command. Like I said, it's cracked to try to keep from tripping my freeze stat. But if we go do the same thing and request that to be 100% open, because all these controls are 24 volts and my transformer's powered, I should be able to drive those actuators. I know I was able to drive the steam actuator down there. That's just a Belimo valve. But yeah, so those are 24 volt as well. It's starting to open up. That'll allow some of this cool air to come in here. See the bypass on the back. So when those close, you completely stop that steam coil from getting air and draw right around it. They're actually fairly clean. I cleaned these up not too long ago, but they got so much dust and crap around here, it's not even funny. These industrial sites are hard on equipment. So now I've got a little bit of airflow. That'll help it cool down faster. And the one thing I didn't verify was voltage out of my disconnect. So we're gonna check the voltage out, all the legs to ground, then we can get in there safely. I'm satisfied. I think that everything's good. It's got no power, nothing's gonna do anything. We'll get in there and check that motor and see if it's a winding problem or a wiring problem. So there's no real good way to get y'all in here. There's no real good way to get me in here. But you can see these are my motor wires there. This thing's been working, so I've got no real worry about the wiring being correct. These are my actual power leads here. So my connections look good. I don't see anything, loose. I've tugged on all the wires. We will have to ohm it out from here. So I'm going to ohm it out from here. I don't know how much I'll get on camera because it's a tight spot. But if I'm still reading open on my ohm readings from here straight to the motor, then the motor's done. The windings are open. I can smell a little bit of electrical burn. I thought maybe I'd have a wire burnt up, but everything looks all right. So we're gonna ohm it out, see if we need a motor, and then go from there. There's 3.9. See if I can get on this other leg. There's 3.9. So I got continuity here. Let's try to get the other one. 3.9. Okay. So that's going to lead me to my motor seems to be okay. So I'm getting an ohm reading here at my motor. I'm not back at my control panel, which means I've got a wire broken somewhere. So I'm gonna have to follow this conduit back. Looks like there's the fitting it comes through in. So let's open that up and start tracing down where I might have an electrical problem. So there's my electrical penetration. I don't see anything broken. And I've tugged on my wires. They are pulled tight right here. And I pulled on them from the motor end too to see if maybe I could pull one out. But that's a long, windy run of that flexible conduit there. So I think what I'm going to do next is try to try to ohm each wire, disconnect them from the contactor and ohm out from the contactor end to my motor end, and see which wire is open, and then I might have to pull a whole new wire. I don't even know if I have any wire or not, or it's gonna be kind of tricky pulling it through there too. I was hoping I'd find a break right here, but I don't, so let's keep on searching. So I've got T1 on my contactor side connected. So if I find T1 right there, and I've got continuity. So let's go to T2 and T3 and do the same thing. That's T1 we just did. That's T2. We got continuity on that one. Alright. Check the last one. T3 is going to be this one here. Aha. I got you. No continuity on T3. So that's my bad wire right there. Alright, now let's find out where. So I got my electrical connection loose and there's nothing broken right here. I've tried pulling on that T3 wire and so I can't pull it through. Like I said, it's a... Wait a minute, what is that? I see it. Oh. Master of the obvious, right? Look at that. So my brakes were right there. No doubt about it. I don't know if I got any more electrical conduit. I'll have to see what I can do. But I need to get that wire out of there, so I'll probably... Shit, I gotta pull a whole new wire back there. I gotta figure out how I'm gonna do it, but you can definitely see that's where it burnt up at. Must have rubbed inside of that middle there. So let's figure out my next step. Once I get a wire to this thing, I bet it'll probably run. And that's why we tripped the breaker. I didn't get any shorts to ground, so it must be just right in there. I bet I do get a short to ground if I started moving that conduit around. So I've got all my wires disconnected here. My goal will be to straighten this out. And maybe I'm still partially connected to this wire. I'm gonna try to hopefully pull it out of there. I've got it loose from that side. I'm gonna take me a new wire on and attempt to pull it through. I don't have any flexible conduit like this, so I'm working with what I got. I found the wire here on site. It's blue wire, but it's the same 14 gauge wire, so I just need to try to get my bad wire out of there. We'll get everything wire nutted back in if I can get my wire out. If not, I might have to, we probably need to run new conduit anyways. I don't know if it was rubbing there from the beginning or what. I've got some seal tight on my truck, but my problem with that is this is a steam coil behind me. So that steam coil is going to get pretty hot, so I'm going to put plastic in here. So let's see if we can pull the wire first and go from there. So I'm not getting any pull on this wire. I found that little copper spot there is my T2 wire, and it looks like this is a cable. It's in separate wires, so the ground might be separate, but I'm gonna have to tear all this electrical out and see about getting some new wire run through here. My T2's nicked right there. It's probably got spots throughout. Like I said, I'd like to replace all the conduit, but I don't have it. At least I don't think I have it. I gotta go check on site here. Maybe they've got something, but I'm probably gonna have to go ahead and disconnect everything from over there, take all of this electrical out of here, and just start over. So I got my wire out, and it's not shielded really, it's not protected. They got it taped right here. It looked like an outer shield or something. That's just wrapped around the wire, so I might still be able to pull one. You can see it's been rubbing. And then there's my bad spot right there. So I'm gonna go check to see if I can find some more flexible cable, see what I can do to get the wire back to this thing, and I'll bet this motor runs. There's my broken wire. I tried pulling on it. They're all trying to come. So it does say on my nameplate here, so draw through arrangements is 104 degree max, 200 and blow through. So blowers there, it's gonna supply up there, so we're drawing through, so I really shouldn't get over 100 and something degrees, at least for what it's showing there. So I don't know what I'm gonna do yet. I'm gonna go try to find some more electrical conduit, and I'm gonna try to just replace all this wire because I found a nick in that other one. So that's where I'm at. There's all the old wire. I don't know what this was supposed to protect, but I went ahead and ran 3 new conductors. Left my ground the same. I got them marked with tape 1, 2, and 3. So I'm gonna take it back up here and put it in. Let's see if this guy won't work. So now I get to put it all back together. Wires marked. We did get one end did not have a wire protector here, so I actually found some, so I doubled them up on both ends. We're gonna get this strung back out and secured, get everything wired back in, and then I'll ohm once again from this side, make sure I got an ohm reading on all my windings, and I'll bet this guy runs. So I got my conduit back up, got my wires pulled through, everything's secured. I just gotta I got some crimp wire nuts I gotta get on there, and then we'll get my ass out of here and go back to where I started at the control panel. So now we got wire nuts on. We gave them the tug test. We're gonna put all this stuff back together nicely. Get all my trash out of here. Get my cover back on. We ought to be good. Couldn't hardly see that ground wire is up in this top corner, and I can't see it. So I'm kind of scrunched back into the corner here so I can do what I needed to do. We'll get that put back together and a cover on and work my way out of here. So cover's back on. Cover's back on there. I left some slack in that fitting there, so they're not pulled as tight as they were. And then I guess, I don't know, they come from the factory with this stuff. This is low voltage, I believe, going over to my control panel. But you can see it's wrapped in whatever that same material is. And then there's my temp sensor there, and none of that's protected at all. So let's get this thing wired in, turn it back on. So we left some slack, I got them all back in. Let's ohm them out. So 3.8. See if I can do this. So I'm wired back in. See my motor. So at 480 volts, I'm going to be 4.2 amps. So that's, I mean, it's right at 5 or just under 5. So I mean, that's reasonable there. It might have just been too quick for this to catch it. With that wire shorting out, I don't know. Like I said, I don't know what happened. When I got here, the breaker was tripped. So we're gonna amp draw on the motor and go from there. So first of all, let's release our overrides. This is my heating valve command. You can see where I've got it overridden there, and then that's the actual temp control. So we'll just click that and hit release. That should allow my steam valve to open, and then where was I? Facing bypass damper. It shows 0. It must have went back. I must not have hit the minimum time. It must have timed out on that one. See if we get some steam. Probably gonna get some water hammer. Yeah, there's my facing bypass damper. So and this is why they haven't been able to leave the air vents open. We're gonna have to bleed some water. Luckily there's nothing but tanks down below me. They are starting to heat up. I can hear the water hammer below me. And my freeze stat right there. She's starting to get hot quick. So I'm gonna make a little bit of a mess, and then we'll get this blower turned on. Alright, I've got power on. Amps ready to go. Everything looks good in here. Cross your damn fingers. Got a little bit of bounce to it. Not too bad. Sounds good. Amp draw's good. Couldn't ask for much better than that. Yep, 3.7 amps, all legs. I'm happy with it. So, never would have thought I found a bad wire. Thought for sure I'd have a bad blower motor. And we can see our temp. Supply temp's gonna start climbing. And we ought to be good everywhere else. We are overheating our space because of the cracked facing bypass damper, but that's kind of what we had to do to get past the control problem that we had. But anyways, this guy's running. I'm happy with it. Leave a trade better than you found it. We'll see y'all next time.